Okay, this is number 1 on the Target 4 worksheet. We have a proof to do. Given E is a midpoint of DB and DE is congruent to CB, we're trying to prove EB is congruent to CB. So I'm going to start with a given statement. There are 2 given statements, but I just want to use one for now. So I'm going to start with my number 1 here is going to be E is the midpoint of DB. Okay, so E is the midpoint of segment DB, and that is given. Now, what do I know about midpoints? I have a couple options here. I know that if I have a midpoint, I can say that I have a segment bisector. If I go back and look at this, my statement would then be that because E is a midpoint, E is the segment bisector of the segment. But once I know it's a segment bisector, all that does is take me back to midpoint. So that's not really useful on this proof. The other thing I know, though, is that if I have a midpoint, then I should have congruent segments. So I could do that because there's a lot of congruent segments in the rest of my proof. I have congruent segments right here. I have congruent segments in the proof. So I'm going to use that definition. So again, definition of a midpoint is if I have a midpoint, then I have congruent segments. So what I need to say is that I have congruent segments. And your job is just to identify, well, what are the congruent segments? If E is the midpoint of DB, that means DB is this line here, okay, highlighting it in like a light blue color, and E is the midpoint. Well, that means it's going to split that segment in half. So I can mark the diagram to help me say what to write. Now I know to write that segment DE is congruent to segment EB. So because I have a midpoint, then I have 2 congruent segments. That's my definition of midpoint. Okay, so that's kind of all I can do from midpoint. I have to see, well, what else is there to do? Again, we go back up to our givens and see what we did. So we used this one. Okay, that's done. So now I want to use this one. And this is where the transitive property comes in. What I like to do when I'm using the transitive property is try to line up on top of each other the 2 parts I'm going to use. So right underneath number 2, I'm going to start with number 3, and I'm going to say that other given statement, that segment DE is congruent to segment CB. Again, my reason there is given. And so if you're following a train of thought, I can start at number 1, I can read over to number 2, number 2 makes sense, I can check it on the diagram, I can look at number 3, number 3 says DE and CB, so I'm going to mark that on the diagram as well, DE and CB, and I look for transitive. I want to try to use transitive in a proof as soon as I can see it. I know that I can use it if I can pick out a segment that matches. So number 2 had a segment DE, and number 3 had a segment DE. Okay, so if both of the segments that are with those, if those are both congruent to DE, they should be congruent to each other. So I can put these 2 together. How you draw it is kind of up to you, but you want it to make sense. So because EB, right here, is congruent to DE, and because CB, on number 3, is congruent to DE, that means that EB and CB should be congruent to each other. And that is what the transitive property says. So this would be number 4, and my reason would be the transitive property. That's a new one for us today as well. So transitive property. And that's how you can always use transitive property as well. You can line them up on top of each other. That way you can draw the arrows connecting so it shows. And if we look, that's what we are actually trying to prove. EB is congruent to CB, so we're finished with the proof. You can look at the diagram and you can see because we just said EB and CB are the same, so they should have the same marks. And so everything basically has a blue and a green at this point. So go back over that, watch through it again, try it on your own, watch through it again, try to do the proof on your own a couple days from now and see if those steps make sense.